Alright guys, this video is going to be on using the undetermined coefficients method, or setting up a system of equations to figure out what our coefficients are for this function. So the directions say to write a rule for the function whose graph passes through the following set of points. So first thing we need to do is determine, is this going to be a quadratic function or a cubic function? And it's very simple to tell. Look at the number of ordered pairs you're given. I'm given 3 sets of ordered pairs. So that tells me that this is going to be a quadratic function. And it's going to take the form y equals ax squared plus bx plus c. So I'm trying to figure out what a, b, and c are equal to, and I'm going to do that by using these 3 sets of ordered pairs and setting up a system of equations to solve. All right, so first thing we're going to do here is we're just going to go ahead and fill in and set up each of our equations. So I just have the general form here, which you should always follow. So remember, ordered pair, we've got x and y for each of these. So I am plugging in x, the x value, into each of these parentheses, and then it's equal to the y value. So I've got a times -1 squared plus b times -1 plus c is equal to 0. And if I simplify this, -1 squared is equal to 1, so this is just a, or 1a. -1 times b, this becomes minus b plus c is equal to 0. So there's my first equation I'm going to use. Second equation, I'm using the point 212. X is equal to 2. So in parentheses, I'm going to plug in my 2. And the whole thing is equal to the y value, which is 12. When we simplify here, 2 squared is 4. So this becomes 4a plus, this is just 2. So 2b plus c equals 12. There's my second equation that I'm going to use. And the last one, 5 is my x value, and -12 is y. So I'm going to plug in 5 in the parentheses for the x's, and it's equal to y, which is -12. Let's extend the page. All right, 5 squared is equal to 25, so this is 25a plus 5b plus c is equal to -12. All right, so we have our 3 equations, and I'm just going to come down here and rewrite them. So we've got a minus b plus c equals 0. I have 4a plus 2b plus c equals 12. And 25a plus 5b plus c equals -12. So here we've got our system of equations, and we're going to go ahead and we're going to start solving. So I have all 3 variables in each of these equations, and I've got 3 equations here. So what we want to do is we want to come up with 2 pairs of equations, and you can pick any combination of pairs that you want. I would suggest using this top one in each pair because it's easiest. I wouldn't pair these bottom 2 up because those numbers are a little messier. You can do it, but it'll be more work. So what I mean by this is I'm going to, one of my pairs is going to be these 2 equations together, and my other pair is going to be this top equation with this bottom equation. And the reason being, this top equation, all the coefficients are 1 or -1. So it's really easy to make them match up the coefficients, but with opposite signs, of the other 2 equations. So let's do this first set, this a minus b plus c equals 0, and 4a plus 2b plus c equals 12. So what I'm trying to do here is get rid of one of these variables. It does not matter which one. Pick one, get rid of it. All right, I am going to choose to get rid of a first. So in order to get rid of a, remember we're adding these two equations together. In order for a to become 0, which is what I want to happen, I need them to have the same coefficient but with opposite signs. So right now this coefficient is 1. And the coefficient on a on the other equation is 4. So I need 1 to be a negative 4 and 1 to be a positive 4. So the way we're going to do that is I'm going to take this top equation and I'm going to multiply everything by -4. And I'm just going to write the new equation down below here. So -4 times 1a, -4a. -4 times -b is positive 4b. And -4 times c is -4c. And I can't forget about this y term over here on the other side of the equation. -4 times 0, it's still 0. You won't always have 0 here. You might have an actual number other than 0 that you would have to multiply the -4 by, or whatever you're multiplying by. So make sure you're multiplying both sides of your equation. All right, so next up, what I can do is I can go ahead, I can add these two equations together. I'm just combining my like terms. I've got the same variable, just going to add the coefficients. -4 and positive 4 is 0a, so this cancels. That's what I wanted to happen. 2b plus 4b is 6b. This right here is a 1c. 1c minus 4c, or 1c plus -4c, is -3c. And 12 plus 0 is 12. So here I've got a new equation, which I'm going to need in a few minutes. All right, let's go to our other pair of equations. So again, the whole point is I'm trying to get one of these equations, one of these variables to cancel out. So I'm just left with 2 to work with, so it's much easier. So in this first pair, since I got rid of a, I have to get rid of a again in the second pair. So let's go ahead and rewrite our two equations here. So I had a minus b plus c equals 0. And the other one I'm matching it up with is that bottom one now. So 25a plus 5b plus c equals -12. All right, so up here in the purple, we got rid of a. So I have to get rid of a down here again. So here's a 1a and a 25a. The easiest way to do this is multiply this top equation, really the only way, by -25, and I'm multiplying everything. So I'm going, actually, I don't want that line there, so let's get rid of that. Gone. All right, I'm just going to rewrite, I'm going to multiply this -25 in, and I'm just going to rewrite it down here. -25a plus 25b minus 25c equals 0. And I'm going to add these two equations together. And when I do that, my a's are going to cancel, which is what I wanted. 5b plus 25b is 30b. This is a 1c. 1c minus 25c is -24c is equal to -12. So here's my second equation. All right, we're almost done with the worst of it. So I'm going to take these two equations, my two new ones that I just came up with that don't have a's in them, and I'm going to put them together. And again, feel free to pause this video at any point if I'm going too fast. Just trying to get through it. All right, so I have my two new equations here. And now what I want to do is I want to try and get rid of b or c. Again, you can choose whichever variable you want to get rid of. I think I'm going to go ahead and get rid of the b's first. So I've got 6b here and I've got 30b on the bottom. The number that these two have in common is 30. 6 divides into 30 evenly 5 times. If I want to get rid of b when I add them together, one needs to be a -30 and the other needs to be a +30. This is already a +30, so I'm just going to do all the work to this top equation here. And in order to make this -30, I'm going to multiply by -5. So I'm going to distribute -5 into everything. So that's going to be -30b plus 15c equals -60. So this is what I was talking about. I'm taking this number, this -5, have to multiply it by everything, even on the other side of the equal sign. So -5 times 12 gives me that -60. All right, got my two equations here, and go ahead and add them together. And when I do that, I should be left with just the c term. The b's should cancel out. So when I add these together, 30 plus -30, that's gone. I've got -24 plus 15c is -9c, and -12 plus -60 is -72. And here I've got just one variable and a very simple equation. I can go ahead and divide both sides by -9, and ooh, I've got c. C is equal to 8. So look, we've got one of our coefficients. I only need two more. The hardest part of this problem is officially over. So now you are just solving or substituting back into other equations, solving for your remaining variables. So I still need to figure out what a and b are equal to. So I'm going to scroll up a little bit. Remember these two equations that I came up with right here when I got rid of a? And then I just added those together to get rid of b, and I solved for c. I'm going to choose one of these, and since I now know what c is equal to, I'm going to plug that number in for c, and I'm going to solve for b. So I'm going to use this one right here, the 6b minus 3c equals 12. Come over here, I've got 6b minus 3c equals 12. All right, I now know from over here that c is equal to 8. So I'm going to take this 8 and I'm going to substitute it in for c. So I've got 3b minus 3 times 8 equals 12. And I'm just going to solve this equation. Woohoo! What happened? Click something. Sorry, guys. All right. I am going to just solve this for b. So 6b minus 24 equals 12. Gonna add 24 to both sides. Gives me 36. Divide by 6. And b is equal to 6. All right. We're almost there. We've got c is 8. We've got b is 6. Now I need to figure out what a is. So I'm going to go back up to my original equations up here. Look at all this beautiful, beautiful math. All right. Do you see this equation right here where I've got a minus b plus c equals 0? This is going to be the easiest one to work with. I now know what b is and I know what c is. This whole thing is set equal to 0. I can very simply solve for a. You can use any of these three equations to solve for a, but you're going to have more math to do with all these numbers in front of the variables, more multiplying and adding. So use the top one. Use the most simple equation that you have. So I'm going to go back down. All right, and the original equation was a minus b plus c is equal to 0. I know that b is equal to 6 and c is equal to 8. So I'm just going to substitute these in. Don't know what a is. A minus 6 plus 8 equals 0. Combine like terms. -6 plus 8 is 2 equals 0. Solve for a. Subtract 2 from both sides. A is equal to -2. So now I know that b equals 6, c equals 8, and a equals -2. So now I just need to write my final equation, my final function, which was y equals -2x squared plus 6x plus 8. And there we have found our rule using systems of equations.